Hello! Today we're going to talk about resistance dimmers. Like my previous video, this was inspired by a picture that someone posted on a theater history Facebook page. Actually, it was two pictures of people running old dimmer boards. And there were some people who had no idea what they were looking at. Well, they were resistance dimmers, and I've got a set of them, so I figured I'd do a video on it. A resistance dimmer is really quite simple. You have a very large variable resistor, also known as a rheostat or a potentiometer, depending on how old you are, and it is hooked in series with your lights. That's it. You have power source, big resistor, lights. Done. The power flow through this is also pretty simple. We have plugs on the front so we can plug in our lights, and then the neutral from the plugs comes down here to a little screw terminal on this plate, which then goes around here to this variable resistor, and then goes across this wiper arm to the other variable resistor, where it goes around and then goes back out again. Moving this lever moves that wiper arm, which means that the electricity has to travel through more or less of the variable resistor. Let's draw this out, maybe it'll be a little bit clearer. Alright, so here on our chalkboard, we have our voltage source, we have our lamp, we have our variable resistor going to our neutral. So let us say that, let's use different colors of chalk, let's say that we have it at off, and our wiper arm is set like this. The power comes through here, goes through our lamp, comes down, then has to travel through the entire resistor before going across the wiper arm and traveling through the entire other half of the resistor before going out to our neutral. If we set it to full, use blue this time, it comes through our lamp. Oops, forgot to draw the wiper arm in. If it's full, the wiper arm's at this position. Your power comes from your voltage to your lamp, down here, and then just goes straight through the wiper arm, passing the bulk of the resistor. So each of these levers is hooked via this solid rod to the wiper arm on one of these plates. In this particular setup, the rod is fairly short because the plates are right here. On larger ones, you would have much longer rods extending sometimes even to the floor above or below you, so that you could have room for all of these massive plates. Because despite their size, these don't have a lot of capacity. I mean, each one of these plates, and I've got 3 of them here in this pack, is a 500 watt dimmer. Even our old CD80 can do 2.4 kilowatts per circuit. Each lever has 2 little loops that ride on a sleeve that rides on a big metal rod. There's a collar that both keeps the lever from drifting back and forth and allows you to link them all together. These collars have a little notch in them. So when you put them back to where they belong, you can then twist this lever, there we go, and drop it into that notch. So now when I turn this lever, it's moving the entire sleeve and collar assembly, which means if I then drop this one, I can now raise and lower 2 channels. If I drop that one, I can raise and lower 3 channels. As you may have noticed, though, as you start adding on the channels, it requires more and more force to pull these things back and forth. I know someone who worked with these when they were still a thing, and if you were a particularly slender technician, you not only would wind up two-handing it, but sometimes also just lifting yourself clean off the ground and hoping that your body weight would be enough to dim that particular cue. A resistance dimmer is a fairly straightforward application of Ohm's Law, which states that voltage, amperage, and resistance in a circuit are all related. In our case, our voltage is more or less fixed. We're changing the resistance of the circuit, and that changes the amperage. The dimmer contributes between 0 and 164 ohms, and the lamp contributes, and this is a 500 watt cyc light, contributes between 27 and 4 ohms. The lamp actually becomes a worse conductor as it heats up. Which, I was actually kind of surprised to see that that number was that low. I mean, this little guy that you can't even see is a 150 ohm resistor, but that's a 1/4 watt resistor, not a 500. So if I grab my calculator, and we start doing the math, 120 volts divided by 171.4 ohms, that gives us 0.7 amps. We do 119 divided by 74.4. At 1/4 power, we're drawing about 1.6 amps. At 50%, 118 divided by 47.2, 2.5 amps. And 118 divided by 35.8, 3.3. And finally, at full power, 118 divided by 28.1, we are drawing 4.2 amps. Now, I also took the liberty of measuring the voltage drop across the dimmer and the lamp at these various intensities. I'm not going to calculate all of them, but I'm just going to show you the full, half, and out, just so you can see something interesting about this. So, full, we're doing 4.2 amps. The dimmer has a voltage drop of 0, so it's drawing approximately 0 watts. 4.2 times 115. The lamp is drawing 483 watts. 500 watt slake light, about what we're looking at. At 50%, we are pulling 2.5 amps, and our dimmer has a voltage drop of 71 times 2.5, 177.5 watts, and the lamp is getting 46 times 2.5, 115. When the whole thing is out, we are drawing 0.7 amps times 115 across the dimmer. So we have 80.5. And the lamp, 3 times 0.7, 2.1. So, yeah, at 50%, our dimmer is dissipating almost 180 watts. My father worked on a theater when he was in school and remembers cooking toast on these during very dimly lit romantic scenes because they would generate enough heat. So, resistance dimmers are large, they're not very efficient, and they have another weirder problem. They have a minimum load as well as a maximum load. Yes, this is a Ward Leonard Electric Company Vitrome theater dimmer, and its maximum watts is 500, and its minimum wattage is 250. Let's demonstrate. I have a board here with two 150 watt light bulbs mounted on it. One of them is currently unscrewed to the point where it doesn't make contact. If I plug the system in, it currently only has 150 watts of load on it. And that happens. Now, if I just simply reach over and screw this light bulb in till it makes contact, now I have sufficient load, I can actually take it all the way out. And then I can just go over here, lights go up, lights go down. If I am to unscrew one of these, the other one starts glowing again. Having your light faintly glow like this was known as ghosting, a term that is still used today to indicate a light that is glowing faintly when it's not supposed to be. The solution to this was you added a ghost load, which is just a fancy way of saying you plugged in a twofer and then you plugged another light into it with all the shutters pushed in. You would just add load onto your circuit until you had exceeded the minimum wattage of your dimmer. I've actually heard ghost loads used fairly recently when people were dealing with LED lights. Once again, they're drawing so little power that the dimmer is not responding properly, and so you're adding extra load to it to make the dimmer behave itself. When I was a student technician here at university, one of the questions on my final exam was explain the difference between a ghost light, a ghosting light, and a ghost load. They do make a very satisfying noise, but still, I'm glad we don't have to use these anymore. There was actually an even more primitive and more terrifying precursor to this, but we're going to cover that in another video. So that's all for today. Thank you for watching.